I'm not sharing anymore.
You're correct.
Okay, we start 10 minutes now and we'll get on the quiz. Yeah. If you have any questions during the quiz, please let me know. Also, for question 2, really think of bid mass. Think of bid mass carefully each step you do. Think of which one you do first, okay? Very important. Sure, I'll put a timer. Let's run to the bathroom.
Can the numbers go to negatives? Can I get a toilet?
Yeah, sure. See any help? Guys, time's nearly done. Leave it to the left. Then oh, no sound. Okay. All right. So that's it. Now we'll discuss the quiz. So we went. Okay. All right. So you guys can see my screen. The quiz online. I hope so. We're going to start discussing now. All right. So I'm not going to discuss these questions too deeply unless you guys ask me. Please let me know if you want me to explain this one, because I think I'm going to go focus more on the second section. But the first one's just 27 squared, which is 27 times 27, right? By the way, if anyone's not finished the quiz, you can keep going, but just pay attention to what the answer as well, okay? All right, so 27 squared is 27 times 27, right? Which, if you just do the long multiplication, you should get 729, right? So if you don't, that's not a big deal, but the important idea is that you get this. But if you're going to make a mistake here, just, next time be more careful with the long multiplication, right? So the important idea is squaring the number, multiplying the numbers together. So that's the answer to that, 729. Second question, 38 squared, same thing, 38 times 38. You should end up getting 1444. Right? Let me check. Yeah, 1444. Any questions with the first two? No? Okay. All right, What about negative 7 squared? Can someone tell me the answer to that?
The 49.
Right?
49.
Yeah, perfect. It's negative 7 times negative 7. Because they multiply negative by negative, the negative will cancel. Right? So 7 times 7, which is 49, like you said, Arjun. So that's very good. Oh, sorry, was that Arjun or Johnny? It's hard to tell on Zoom.
It was me.
Okay, Arjun, yeah. Sorry, I haven't had Johnny do over Zoom. Wait, Johnny, are you there? Hello?
He went to the toilet.
Oh, he went to the toilet? Okay. All right, so for the next question, it's negative of negative 18 squared, right? And what's the answer to that?
1584.
That's a little bit big. You have is negative of, in brackets, negative 18 times negative 18, right? Because you're negativing the answer at the end before you do the squaring. Negative 18 squared is going to be the same as 18 squared because it's negative squared is positive. So if you calculate that, you should end up actually getting, let's do it together. 8 times 8 is 64. 4 carry the 6 times 1 is 8 plus 6 is 14. Right? Bring the 0. 1 times 18 is just 18. If you add these two, you get 324. What you have is negative of 324. And the negative 324 is just there. We're done there. Right? So what happens is when you square this negative, it became positive, but at the end, you also multiply by negative again. Right? And that became positive. So the answer, overall answer became negative. So, does that make sense? Okay. Hope it did. Now we'll go to the next section. Just expressions and squares. By the way, I'll put the solutions from now on as well, so you can access it after the class. All right, so expressions and squares. Can someone tell me what should I do here first, following bid math?
Yes.
Yep, do inside the brackets first. And inside the brackets, I'm gonna do the squares first. That's more important than subtraction. So I'm gonna do 17 squared. By the way, if you guys want to set up, if you want to like set out work nicely in a way that you make less mistakes, what I recommend is you do 1 or 2 steps per like line per each equal sign basically, and then you have any sort of big calculation you do on the side. That's how I approach it. If you guys want to do it like that, it's fine. If you do it differently, that's fine as well. But if you find yourself making silly mistakes, this is a really good way to minimize silly mistakes because you just very step by step and you make less mistakes that way. So 17 squared, if you do it, I think it's 7 times 7, 9, 4, 1, 11. It's 170. So it's 289. Right? It's 289 minus 1 divided by 6 plus 5. We'll keep finishing the bracket, subtract it first. So 1 plus 2, 8 divided by 6 plus 5. Okay, here, what do we do first?
Division.
Yeah, division. From bid mass, division is what we do next. I'm not going to do the division, but the answer you should get when you do it is 48. Right? You should do a long division here, maybe on the side like this, and you should get 48. So 1 plus 48 plus 5. And here it's pretty simple addition. It ends up with 54. Any questions with this answer? No? Okay, then we'll move on. For the rest of them, they're all very similar to the part A. So I'm not going to explain it unless I'm going to put the answer first. And if you have any questions with it, please let me know. Yeah, I think we might discuss D though. So, but if you have a question with B or C as well, please let me know. So the answer to B is, give me a sec. Well, there seems to be an error with this question. It ends up in a fraction. I think that's why it becomes really hard. I think I'm going to do 4 times 4.
Some of them were also like decimal, like negative numbers on the other page.
Negatives are fine, but I think fractions that's a mistake for me.
Oh, okay.
Yeah. So I think this one, if you did do it, it's plus 169 on 3 plus 13. Oh, I see why this question must have been hard. I'm sorry about this. It's 44 plus 169 on 3. Put in a fraction is 301 on 3, which is really hard to do. Right? So don't worry if you guys didn't get this one. It should have been minus 4 times 4 squared, which is my bad. Right? So because it ends up being a really ugly fraction, which you guys probably haven't done much of yet, right? So please bear with me and ignore that one. But I think an important lesson you guys should take from this is if you get stuck on a question, I mean, I shouldn't have made a mistake. I do apologize for that. But if you get stuck on a question for a little bit, maybe spend 2 minutes thinking about it. But after that, move on, right? Because there's more questions to go. But there's always going to be in a test. There might be a hard question. So when that happens, think about it for a minute or two. But after that, don't spend any more time. Right? If you're stuck, then please keep moving on. So this one is 301 on 3. And you guys, I didn't expect you guys to do this just because, I haven't taught fractions yet. This is the exponents unit, so you work with whole numbers only, right, for now. This one, C, I don't think there's any errors. Negatives are fine with us. Right, so what do we do here first? Should anyone to get the answer? Or do you want me, I'll give the answer or not? Okay, it seems that not many people got the answer, so we'll discuss this as well. Okay, so here we go. So we have following BIDMAS, we always do brackets first, right? So we should do.
Wait, is the answer 61 over 16 as a fraction?
No, it's a whole number. It's the answer.
Oh.
So what we have 1 minus 4 squared, right? Which is, you do the brackets first, which is 1 minus 16 squared.
Wait, is the answer 5?
No, I don't think so. So then if you do the brackets again, get negative 15 squared divided by 3 plus 64 divided by 4 squared. Here's where we do all the powers first. So because BIDMAS, we finish all the brackets now. And we're going to do the powers next, right? So the I of the BIDMAS. So I'm going to do the square, negative 15 squared. So if you do negative 15, that's same as 15 squared, because it ends up being positive. So you can calculate that, right? It should end up being 225, right? And you have divided by 3. And then you do 64. Do you do 4 squared, which is pretty simple, which is just 16. Right. So just if you really focus on each aspect of BIDMAS. So now we're done with even little checklist. I'm done with I. I have division, multiplication, addition, and subtraction. Are the remaining ones, the ones I need to do, what do I do first here? What do you guys think?
Division.
Yep. Which division though? Actually, it turns out it doesn't matter which one you do first. But in general, a really good idea would be do the left one first. Do the one on the left, then go to the right. Because doing the one on the left onwards will never be wrong. Right? Sometimes if you do the one on the right, it can fail, but here it's fine. Sometimes it can be wrong. So, but if you do left to right, it will always work if they're the same. Right? So when they're equal in BODMAS, so if they're both division or multiplication, then do left to right. Right? So that's important tip. So first priority is BODMAS. Second one is left to right. Think like a hierarchy. So your first thing is you obviously do one in BODMAS first. But if they're equal in BODMAS, then do left to right. It will never fail you. Okay. So 225 divided by 3, you can do long division, blah, blah, blah. I'm not going to do this stuff just because you guys should already be comfortable. Right? And I'm not going to give you the answer. Do the rest of the working. I'll let you guys do that on your own, but you should end up getting 79. Okay, so try to do the working and get to this answer. All right. Any questions with that? Any questions with the work until that step? You know what? I'll give you guys 2 extra minutes to do the questions in the quiz, just because I think you guys probably got stuck on part B there, right? So I'll give you guys 2 extra minutes just to get one with part C, D, and maybe look at the challenge as well. Okay. Did you get 79?
Oh, I just realized.
So there should be an X anymore because you replace X with negative. All right, we'll discuss this now. So these are probably a bit weird for some of you if you haven't seen algebra before. So hopefully we will get used to this over time because we're just trying to build up to basic algebra in a few chapters time. All right. So did anyone do part D?
I did it.
Yeah. What did you get?
1.
1?
Yep.
Okay. So I think you were very close, but you made a small error.
-1?
No, it's still positive because square is always positive, but the number here is -3, not +3.
Oh.
Right. So what we're doing is 8 minus 2 times -3. Because remember, actually, first of all, I need to explain what we're doing in this type of questions. It's saying you're trying to find this, but we don't know what x is normally, but it's giving a value of x. So all you got to do is you replace that x with that value to just put in. right? So you replace x with -3. So it ends up being 8 minus 2 times -3. Also, another thing is, I think if you haven't seen algebra before, 2x means 2 times x. So what we have is 8 times minus 2 times -3. Right? So it's times the dot there, divided by 4. So it's not 8 minus 2 times 3, which is 8 minus 6. It's 8 minus 2 times -3, which is 8 minus -6. Does that make sense? You don't need the brackets, by the way. You can have it. It doesn't make a difference. Divided by 4 squared. What's 8 minus -6? Minusing or subtract negative is same as? Yeah. Right. Because minus sort of reverses, and 2 reverses goes back to the original direction. Plus 6 squared. 4. So you end up being 14 squared divided by 4. Right. And then here you can do 14 squared on the side. Like that. Keep going with this. Tell me what you guys get.
704.
Sorry?
704.
Shouldn't it get smaller because you're dividing?
Oh no, 14 times 14.
Or 14 times 14? It's a bit smaller. 4 times 4, 16. 4 plus 1, 5. 0 times 14. 196 divided by 4. Just be careful doing long multiplication. Right? I think you guys should be comfortable. I think just try to avoid silly mistakes. Right? But if you have any questions with how I got, like, if you're making a lot of long multiplication questions, like silly mistakes that you think you can improve on, please, after the class, if you want, ask any questions. For now, actually, even now, if you want to ask a question on long multiplication, please let me know. But it's 14 times 14 is 196, right? And you do divide by 4. You can do that on long division as well. You end up with, I'm not going to do it, but I'm sure you guys know how to do this one. That's from last chapter. It's 49. Right? So I think one thing is, for this section, is just about being sharp with your doing the basic operations. Because now once you get to powers, addition, subtraction, multiplication, division, they should be easy. Right? Not easy. You should be not making silly mistakes. So you should be really, when you're doing them, focus a lot, because you've already done the hard work here. This is the hard stuff. This is stuff we new for you. So the section at the bottom should be where you don't make any mistakes. If you make any mistakes here, it's fine, because we're still learning this part, right? So we're trying to learn those mistakes. So we shouldn't try to should be very careful once you get to this section, because it's like the home straight. We already done all the work in the first section. You don't want to make any mistakes once you get to stuff we already know. Okay. All right. The challenge we won't discuss is not as important, but I'll put the solution after class, all right? So that's that for the quiz. Any questions with that? No. All right. We'll move on to today's content. The quiz will go up later today. Okay. So here we go with chapter 2 on exponents. Look at this. Start it next week. Do you have last week's handout? No. By the way, usually we do run a bit into last week's handout, so I'll always bring the previous week's handout. All right. Do we have the book? Okay. We'll only do a little bit on the last week's handout, then we move on. We have about 5 more pages left. All right. So does everyone else have the access to the handout from last week?
Yeah, I have it.
Okay, nice. So we'll get started now. So the first section, is squares of reciprocals, right? So I'm assuming you guys are comfortable with all the previous section. We've done the quiz and everything, so hopefully you guys are sharp with that. Squares of reciprocals. And here, the concept we're going to use is multiplying fractions. Have you guys done that in school, or yeah? Because the thing with fractions is adding fractions is really hard, but multiplying fractions a lot easier, right? So not too hard to do them. So what we have when you square a number, remember the definition of square? You have squaring a squared means what? What does a squared means? It means a times by what? Yep, so a times by itself, which is a times a. No, squared means you multiply the number by itself. So multiply by a. This is a definition, very important definition. You can always refer to this in your handout. This definition is going to come in handy all the time, right? It's a pretty basic definition, but the basic definitions are good ones because we use them everywhere, right? So that means if I have 1/5 squared, it doesn't matter if it's reciprocal, it follows the definition, the same as 1/5 times what? Yeah, times by itself, which is 1/5. So does that make sense? I'm just using the definition we have here, right? Math is all about using definitions and then doing as much as you can with the basic definitions. Right, so we extend the definition to fractions or reciprocals right now. We're not doing proper fractions yet, just the reciprocals. Right? And when you have that, what do you get? How do you multiply two reciprocals together? You multiply this, you multiply the top part together, right? You end up with 1 times 1. Bottom part you also multiply together. With 5 times 5. Right? That ends up being 1 on 25. Okay? So we'll go through part B together as well, but this time I want you guys to help me out. Okay? So I want you guys to guide me through the working. So for part B, what should I do first? Right? What's my first step here? Someone online tell me?
Positive 1 over 49.
That's the answer, correct? But I want you guys to guide me. Let's say I don't know anything about this. I want you guys to explain to me how to do this.
1/7 times 1/7, and then 7 times 7 is 49.
But why do you do 1/7? Because when it's negative, it's at once negative 1 on 7 inside.
Well, because there's 2 negative, it cancels.
Oh, okay, so you do negative first, but then you realize it doesn't matter, so you do positive. Is that what you were saying?
Yeah.
Okay, nice. So that makes sense. And then, like you said before, you multiply it together and you get 1 on 49. Okay, so that's good. Right? The key point here is that multiplying reciprocals are pretty simple. You just multiply the bottom parts together, or it's just actually usually ends up just being the bottom part squares, but the top part square just 1, right? And again, the negative part doesn't matter. The square of a negative reciprocal is just positive again. This is like before. Square of negative is positive. That idea still keeps going. All right, now here's what I want you guys to do yourself. These drills yourself. We have 1 on 9 squared, negative 1 on 17 squared, and also part C. So I'll give you guys about 5 minutes to do this one. So guys, while you're doing this, I just want to make an announcement. First of all, next week is the last week of class for this term. So we'll have 2 weeks holiday after that, and we'll get started back on the 7th. Okay. And second thing is I'm thinking of doing a holiday test. So if you guys can make it, I'll try to organize a time in person during the holidays as well. If you guys can make it, that'll be great. But if not, I can send you the online PDF as well. So I'll send details about that to your parents. Don't worry too much about it. But there'll probably be a test which will be on these 2 topics, on the first chapter of powers, of arithmetic, and chapter 2 on powers. Okay. So keep that in mind. By the way, there's 2 extra questions on the next page, so keep going with this as well. But actually, we'll discuss A, B, and C first. Also, for part C, you can do it directly multiplying, but the shortcut if you want. That'll make it a little bit easier. Think about what you can do. Can you simplify something inside first? You make it, like normal reciprocals look like what? Part A and B have the numerator is numerator like the top part on the fraction. That's equal to 1, right? So that was a little bit easier because I've run the fraction smaller, right? Can you do something similar to part C? Can you? Can you have a one numerator have B1? Yeah. That'll make smaller numbers and a lot easier to calculate, right? So do you guys hear what I was talking about part C? How you can convert to like similar to part A and B to make the answer? Okay. Also, if you guys have finished the question, please send it to me on the chat. Okay, nice. Yep, I did see it. Yeah, part A, both you, Ryan, and Say, are you correct? Send it to my host account, by the way.
I sent my one over.
Yeah, that's correct, Arjun. Very good. Yep, that's good, Saya. Part B as well. So I'm gonna put the answer to part A now. If you have any questions with it, please let me know. Okay. 1/9 squared, 1/9 times 1/9, which is 1/9 squared, which is 1/81. So Saya, part C, don't forget that if you do multiplying, you also multiply the top part together. So you've done like the bottom part squared together nicely. You also multiply 2 numbers at the top together. Does that make sense?
Yes.
Okay. Yeah, very good, John. Oh, Janitu, you're very close. But don't forget, it's negative times negative. What happens then? The sign becomes?
Positive?
Oh, did you have a dash there or
Yeah, I put a dash there, not a
Oh,
such.
sorry. Yeah, that's correct. That's right. Sorry. That's my bad. put up. Also, say your answer before had the right denominator, so you didn't need to change the denominator. I think it was the numerator you change the top number in the front. Right, so I'm going to put up D and E now, but keep going with B and C if you're not done. So what I meant to say is that it's, could you write down B, because I'm going to quickly explain C. Is when you multiply top 2 on, what is it? Give me a sec. You got it done? Very nice. So when you get 2 on 46 squared here, the answer just being 2 on 46 times by 2 on 46, right? You multiply this part, fine. You got the answer right there. You also got to multiply the top numbers together. So denominator wasn't the issue before, it was that you didn't multiply 2 numbers at the top. It doesn't stay the same because you're multiplying with 2 different numbers. It stayed the same in A and B because 1 times 1 is 1. But 1 times 1 doesn't change the number, but 2 times 2 will change the number. So it's not going to stay the same. Does that make sense? If it's confusing, please let me know. I can explain again. I'll explain the answer to B. So it's 1 on negative 17 times 1 on negative 17. Right? And here we do, top number is just going to be 1 times 1, right? Which is 1 times 1 is just 1. And negative 17 times negative 17 will become what? What does it become, Janidu?
What?
What's negative 17 times negative 17?
Oh, I'm still doing that one. Oh, negative 17 times negative 17.
Yep, speed.
I need to do that one, I'm pretty sure.
You send the answer.
Oh. Oh, yeah.
No, not CB.
My, audio is, breaking up on you. I can't hear.
Oh, so not C, so part B.
So for part B?
Yeah.
Oh, okay. I got 1 over 289.
Yeah, so that means 17 times 7, negative 17 times negative 17 is 289. Right? So just got to multiply each part separately. Same thing for here in C. I'll give you guys time to do. Wait, the idea is you multiply the 2 by the 2 here. You multiply the 4 by the 4 here. So the 46 by the 46 here. It's like, what does multiplying by reciprocal become? Remember from last chapter?
You have to switch the numerator.
No, that's dividing by reciprocal. Multiplying by reciprocal is just the same as division by the normal number. And it will make a lot more sense when we do fractions, but for now, just sort of, I guess you have to take my word for it. I can't really explain it fully, but I'll explain that once we get to fractions. But for now, when you're multiplying just like a number by a reciprocal, convert that to division. Right? So to convert second number to division. So multiply by the reciprocal is the same as division by the normal number. Okay, so we'll go through part C together. It's going a while. Can someone tell me what they get for the numerator here? do you get, what's the numerator? It's just the two numerators multiplied together, right? What does that become? Okay, in that case, I'll go through it myself. So the numerator is 2. So if you multiply 2 by 2, you end up with 4, right? And then in the other case, the denominator, you multiply 46 by 46. That one's too big to do in our head, so we should probably do on the side. 46 times 46. So you do 4, 6 times 6 is 6, carry this 36, carry the 3. 6 times 4 is 24, plus 3 is 27. 2, 7, the 0. You do 46 times 4 now. 4 times 6 is 4, carry the 2. 4 times 4 is 16, plus 2 is 18. 40. 6, 11, carry 1. 2116. That's 4 on 2116. That's one of the answers. That's correct. Right? Any questions with this answer? How I got here? Anyone? If you guys got, did you guys get the same answer online? I'm gonna take that as a yes, hopefully. If not, please let me know.
Yeah, I got it.
Okay, nice. But there is another way to do this, right? And the thing is, once you get to fractions, you'll realize that this fraction is called an unsimplified fraction. Is that you can, there's a way to make it smaller, right? And the way I simplify is just canceling all the common factors between the numbers. So here, both numbers have common factor of 4. If you divide the top and the bottom by 4, you should get the simplified form. But you can actually get the simplified form from the beginning if you cancel it early. Simplify early. So because simplifying here is really hard because this number is really big. It's really annoying to do it. So a more efficient method would be to simplify at the beginning. If you simplify 2 on 46, what does that become? 1 on, because you choose a common factor. 2 on 46 becomes 1 on what? Sarah? Yeah.
1 and 3.
Yeah, perfect. Ends up being 1 on 23.
Yeah.
Because both this, if you divide 2 by 2, you get 1. If you divide 46 by 2, you get 23. It just ends up being 1 on 23. Divide both the top and the bottom by 2. I
So
just wanna...
you divide it half.
Yes, divide by 2 or multiply by half for each part. Simplify first, right?
Okay.
If it's possible, right? You can't simplify A and B, but for C, you can simplify. These ones are already simplified, but because you can't simplify, try to do that first always. And then you square this now. Now you have 1 on 23 times 1 on 23. 1 times 1 is just 1. And 23 times 23, you can do yourself. I think it should just be 529, I think, if you do that multiplication. So this is, if you simplify this fraction yourself, you're gonna end up here. But it's just a lot easier if you simplify early than having to simplify this really big and ugly number, 2116.
Okay.
So with fractions, a really good tip is simplify as early as possible. Whenever possible, simplify. Simplify whenever you can. So the earlier you do it, better as well.
Yeah.
Then you just get smaller numbers to work with. Okay. Now we're going to go to part D and E. Then we'll finish up with this section. Any questions with that before we move on though? Any questions with A, B, and C? Nope. Okay. Before we do this section, I want to ask, do you guys recall something? Do you remember what if you multiply a number by a reciprocal, what does that become? What's the same as? I think we did this in previous chapter. Is there an easy way to do a question like this? When you multiply with the reciprocal, you can make it easy by doing what operation instead of multiplying? The problem here is this reciprocal is ugly. You want to work with whole numbers. So 8 times by reciprocal, same as 8. What do you do to 8? You want to make the second number into normal. Get rid of the reciprocal, make it go away. Becomes division. Very important concept. It doesn't make full sense to you yet, but it's just because it's a definition, right? So there's no way to explain definitions. You just have to trust them, and you just have to remember them, right? So 8 times by reciprocal, same as 8 divided by the normal version. Very important concept for this question. Please send me your answer through when you finish. Okay. Yep, that's good, Arjun, but can you simplify it to a whole number? Because remember, you multiply by reciprocal, that becomes division by the whole number. Yep, good. By the way, if anyone's these two are a little bit trickier than part A, B, and C. So please, if you have questions, let me know. First of all, what's 8 squared?
64.
64, good. What's 1 on 4 squared?
16.
1 on 4, so
116.
yeah, 1 on 60. And what do you do here from when you get these two numbers?
64 over 60. Yeah, 64 over 60.
64 over 16.
Which is equal
That
to
would be-
4.
Which is, you can write this also as 64 divided by 16, which is equal to 4, like you said, right? Good. Very nice. I will move to E. Right? I'll give you guys kind of a minute or so to do this one. And then we'll discuss as well. Good. Did you switch them around? Because you can order multiplication, well, it doesn't matter, right? Who said the speaking language to Italian?
I think I might have done that trying to do English because I can't really hear it, so I had to put the subtitles on.
Oh,
Yeah.
please, if you didn't hear something, let me know. I can repeat, okay?
Yeah. Yeah, I think it's something with the laptop because it's like echoing and stuff. Like
that-
in a very like deep tone.
Is it for everyone else the same?
No.
It just like buzzes. Like the laptop just buzzes when you guys talk.
Oh, okay. I'm hearing, oh, I think it's because, I think that happens sometimes. Oh, wait, I think I can hear your audio.
Yeah, I think you guys can hear it, but I can't like hear your guys' audio.
Oh,
Pretty sure it's something with the laptop.
oh, okay. But still, just let me know if you want me to repeat anything, okay?
Yeah.
Okay, so for part E, we're going to go through it now. So what we have is, we have a reciprocal squared and also a full number squared, right? So obviously, actually, the reason we didn't do, we do column bid mass, we do the power first, right? So we don't do the multiplication first, we do the powers first. So what's -1 on 7 squared, first of all? If you square this number here, what do you get? Sarah?
1/49.
Yeah, very good. So it's 1/49. But don't forget, there's a negative on the outside. So we're gonna leave that on the outside still. So it's still there, right? And that's been times by 14 squared. What's 14 squared? On the side, 14 times 14. Right, calculate that. And you should end up with 196. Right? And here, if you're comfortable with fraction, you can write this as -196/49. Or if you're not fully comfortable with fractions yet, another way to do it would just be switch them around first. 196 times -149. Then this becomes division. 196 divided by -49. And this one becomes just, this is the same thing at the end of the day, right? And both of these answers lead to a final answer of 196 divided by 49. If you calculate that, it should be, do long division, you should end up with 4. But since the sign is negative, it's -4. Does that make sense? Anyone online have any questions with this?
No.
No? All right, okay, good. Now we're going to go to the next section, which is actually one of my favorite sections, is distributive properties of squares and multiplications and division. This is going to be like a first shortcut we're going to learn to make these sort of make working with squares a lot easier. Because I'm sure you guys have noticed by now, but squaring gets big really quickly, right? If you just square like 30, it's already like nearly 1,000. right? If you get square 50, you're in the 2000. It's huge, right? Like addition was pretty small. Multiplication got a little bigger, but square gets big really quick. You square a couple times, the number gets ginormous, right? So here, so it'll be good to have shortcuts sometimes, and these are some of the shortcuts we're gonna learn now. So first of all, the first shortcut we're learning is the distributive property of squares and multiplication and division. Do you guys remember the distributive property of multiplication and addition? What is it? A plus B times C. What do we do there? You can expand this out to be. What this became when you expanded the bracket, the C would distribute over to A and to B. Remember that? And ends up being A times C plus B times C. Right? You can also work the other way around. If you have A times C plus B times C, you see common factor of C. Take that out. Factorize. This is called expanding. You go the other way, which is if you have X times Y plus X times Z, right? You have common factor of X. Take that out. Reverse the distribution. End up with Y here, because that's on the left, and Z here, because that's on number Z. And you just add them together. So this is the distributive property for addition and multiplication. Now we're going to distribute property for multiplication with squaring, right? Because this is actually really, really handy. So let's look at this number first. Let's look at this example first. So 25 squared times 16 squared. I want you guys to give me ideas for this one. What do you think we should do first?
First do 25. First do 25.
Squared, yep. And then I'm guessing you're going to tell me to do 16 squared next, right? So do them separately. Because a bit math, do them first. So 25 squared, do on the side. Yeah, I'm going to tell you guys the number just because it's a pretty long calculation, right? 25 squared is 625. 16 squared is 256, right? Just take my word for it for now. And then here you just multiply, right? Multiply two really big numbers. Right, so I know I didn't give you enough time to calculate yourself, but just take my word for it for now, right? The answer to this one is just going to be multiplying these two big numbers. But that seems really long, right? It's a huge 3-digit by 3-digit. We really don't want to be doing that. So we should be. So when you get a really long question, you should be thinking, is that a shortcut? Did I do something? I don't want to be doing this in my hand, because most questions that are on a test that you'll get will be have a short. If it's too long, it's because you're probably missing a shortcut, right? So, and there is actually a really good shortcut. What if we don't calculate first? What if we just expand this out into all multiplications, right? Because remember, squaring is just multiply a number by itself. So use that definition. A squared is A times A. I'm going to show you guys a really cool shortcut here. So we have, let's separate this. This is the first way to do it. So you just calculate 625 times 256. Very long, really boring. Don't like that, right? Second method is 25 squared is just 25 times 25. I'm not going to calculate it yet. 16 squared is 16 times 16. Right? Do you agree with that? I just expanded out the squares into multiplying. Right? And remember, by the commutative property of multiplication means I can rearrange them whichever way you want. I'm going to do this. I'm going to switch these two numbers. See, what I'm going to do is I'm going to pair these 25s up with another 16. So 25 pairs with 16 here, and this 25 pairs with this 16 here. Right? So I end up getting 25 times 16 times 25 times 16. Right? And here's the trick. This is 25 times 16 squared. Think about that for a second. What I have is, I have 25 times 16 we multiply by 25 times 16. By definition, that's squaring. Number 25 times 16 is one number, right? I'm multiplying that number by this itself because we did 25 times 16. Does that make sense to those of you online as well?
Yep.
Yep. And look, here's the thing. What's 25 times 16?
Around 500.
Okay, I want you guys to calculate exactly. It's not too hard.
Oh, okay.
Good. I'm told an answer, and I think it's correct. It's 400. Calculate it, you should get 400. Okay. So what we have is 400 squared. What's nice about this?
It's
what's-
easy to square.
Why is it easy to square? You're
It's an
correct.
easy num- it's a friendly number
Yeah, but why is it friendly?
because it's a multiple of 100.
Exactly. This 400 squared is 4 squared with a bunch of extra zeros. Right? 4 squared is 16. How many zeros do you add?
Oh,
That two zeros being squared is 4. So 2 times 2 is 4. And the reason it's 4 zeros is 100 squared, right? If you multiply 100 by 100, the zeros add up. So 100 times 100 is 100. You know, if you multiply 100 by 100, you end up just getting the zeros because this term requires 2 zeros, and you just multiply by 100, get 10,000. So you just multiply 16 by 10,000. Whenever you're squaring multiple of 100, right? You can just, or 1,000 or whatever, you just double the number of zeros and add it to the number. But does this make sense how we added 4 zeros? Because it's a really important concept we're going to use now for this section. When we explain again, please let me know. Right? It is because we're using friendly numbers square as a shortcut to make these big numbers, big squares easier. Okay. All right. So anyway, that's that done. We'll move to part B now, which is applying the same property to division. So I want you guys to do a similar thing for this part B. Actually help me with that as well. We'll do it together. So I mean, we can calculate them separately, 196 squared and 49 squared separately, but that's probably going to be long, right? You're probably going to want to use shortcut. So what should we do?
Wait, is 49 a multiple of 196?
The other way, 196 is a multiple of 4.
Oh, yeah. Is it a multiple?
Yes.
Then cancel it out.
What does it cancel out to?
So it's how many?
Can you guys check and tell me? You're the ones who are telling me what to do. I don't know how to do this. I need your help.
Oh, it's a multiple. Oh, no. But do we tell you the answer or the steps?
Just the steps, yes. What's 196 divided by 49, I guess?
Four.
Yep, good. It's 4. You check. I mean, long division actually doesn't work. Not my bad. It's 4. Right? And the way we can do it is 196 times 196, because squaring can expand it to multiplication. Divided by 49 times 49. Right? And if you, I mean, I'm not gonna. You can convert all this multiplication by doing the reciprocal stuff, but you can rearrange it. This becomes 196 divided by 49 times 196 divided by 49. Right? If you wanna, sorry.
Then it'll be 16.
Yeah, just 4 squared. 4 times 4 is 16. but this middle step might be a little bit tricky for you. Do you guys know what I did here?
You like rearranged it like there's like a left hand side of the equation and the right hand side. On the left hand side is 196 times 196, and then on the right side is 49 times 49. And you just move 149 from the right hand side to the left hand side.
Yep.
And then
Important thing is I brought the sign with me. You always got to bring the sign in front of it. Very important. So this ends up being like this. You should always bring the sign in front of it when you're bringing the number. So if you're switching numbers, you got to switch it with the sign. If you switch it with the sign, you won't make too many mistakes. If you just move the sign, like move the number around and don't move the signs, you might make a lot of mistakes. Here I moved the 49 with the division in front of it, so that I don't lose anything. So I did that, and then I can just get 4 times 4, which is 16. Right? But obviously doing this every time is kind of long. Right? This is the full explanation for it. But now we're gonna go through. We're gonna learn a property about it that makes it super easy for us in the future. Right? Here's the thing. Look back at 25 squared times 16 squared. Let's write that again. 25 squared times 16 squared ended up becoming 25 times by 16, the whole thing you squared at the end. So we did in part A, right? It's a quick summary of what we did in part A. So what we have is we have a product of two squares. Product means multiplying these two squares, right? It's same as squaring the product, right? We're going to sound a bit confusing, but it'll make sense when I write it down in the equation. So here what happens is we do the square first, then you product. Right? But that's the same as if you do the product first, then you square. Right? So what I mean by that is if you do a squared times by b squared, that's the same as from part similar to what we did here. What does that become? A times b, the whole thing squared. Take a look, compare these two. Compare, all I did was, this is what I did from here in this step. I just did with letters instead of numbers, right? So a squared times b squared, I multiply a by b, then I square it. They're equal. Right? This is a really useful shortcut we can use. Does that make sense? Because the full law is full explanations in part A when we did it, but the shortcut is like this. And I can explain to you again with letters. A squared times b squared just becomes a times b, right? And here's what happens. All you do is you switch the a by the b, right? Ends up becoming a times b times a times b. And that by definition is a times b squared. That's how they equal. This way they equal that. That's why this makes sense. Does that make sense? Any questions with that explanation? Or does it make sense? Because this is important. I want your feedback. I know, like it's probably annoying me asking your feedback all the time, but just for this one, please let me know if it makes sense or not. Because this is a really important property, and we're going to do some questions on it next. Does it make sense or no?
Yep.
Yep. Good. Okay. And same thing with division. A squared divided by b squared. What do you think happens? Very similar to what we did in one before. Becomes what happens inside the brackets next. It's just basically do what we did here.
A divided by b to the power of 2.
Exactly. And the reason is very similar to what we did here. I'm not going to go through that, but this is two very important properties that we're going to use now. A couple of questions. Right? But before we go to the question, I want you to notice a common misconception that I want you to avoid. And that misconception is, if you have a b squared, so if you have like, actually this, you're not going to see too much numbers, but we have 2 times 3 squared. It's not the same as 2 times by 3 squared. Why is that not the same?
It's because for the first one you have to first do 3 squared, but for the second one you first have to do 2 times 3.
Exactly. So because you do 3 squared first, you just end up squaring only 3. But here, because you do 2 times 3 first, you end up squaring a bigger number. You end up squaring 6. That means they're not exactly the same at the end. Basically, this 2 doesn't get squared. It's the difference, right? So some common misconceptions that I want to avoid. Anyway, we'll move to the next section now. Not next section, some problems now. All right. So you can probably do it the other way as well, but I want you specifically, especially part A and part B, they're pretty easy, so you can do it the other way. Do it the way you did before. But I want you to force yourself to really focus on this, using this property. Whenever you have this, put into the brackets first, then do it. Just because part C and D and E and F, you can't do without it. For part C, D, E, and F, it's essential to use the property. But for part A and B, you don't have to. But get good practice by doing part A and B in that way. So I'm going to rewrite the laws. It's A squared times B squared is A times B squared. And the second one is A squared divided by B squared is A divided by B squared. So use these laws. If not, part C, D, and F will be a lot harder. Okay, so we'll do the questions. I'll give you guys about 5-10 minutes.
Do we do the ones you put a star on?
Sorry?
So do all of them.
Do all of the old ones. Sorry, I was trying to say that these ones are easy and the ones at the bottom are a bit harder.
Oh.
Yeah. So here we have 3 to 4. A square, no multiply by 2. When you finish, just send me the answer on the chat to the host account, please. Could you don't think that one's exactly right, Arjun. Maybe check your work again. See which number you're squaring here.
I did it wrong. I think I know the answer now.
Okay. Send it through, I'll let you know again. Okay, so I'll put up the answer to the explanation for part A. Just by using this property that we learned just now. It's closer, but I don't think it's still correct. What we have is 3 squared times 4 squared. If you use a property, it's been in subsequent 3 times 4 squared. Right? 3 times 4 squared. What's 3 times 4? It's just 12, right? And so just being 12 squared. And I want you guys to calculate 12 squared carefully. And tell me the answer in the chat. Yep, that's a good sale. So if you calculate 12 squared, you can end up with, I think, 144. Right, just long multiplication, you gotta be careful. Yep, and with part B, what we have is using the property we learned here. You divide the numbers first. So it's 6 divided by 2 and the whole thing is squared. And that becomes 3 squared, which is just 9. A is 144 and B is 9. So please let me know if you have any questions. But obviously, arithmetic errors, they're not a big deal. If you got the concept, this concept is a really important one. If you can apply it like this, right? That's the more important one. But after that, it's just about arithmetic, so it's about being careful, right? Because we've already done this, we should be reasonable at that. All right. We'll now move to C, D, E, and F. So we'll go to part C now. We have so using this prop, we're just going to keep applying this. It's all about just applying this property that we learned just before, right? So 8a squared times b squared is 8 times b squared. So this just becomes 8 times 125 squared. Right? That's just what's first of all, what's 8 times 125? It's the question.
$1,000.
Yeah, 1,000. Very good. Right, and that just becomes 1,000 squared then. And 1,000 squared just 1,000 times 1,000. The 1 doesn't change anything. You just add the zeros. 3 zeros here, 3 zeros here. Final answer will be 1 with 6 zeros in behind it, which is 1,000,000. And that's our answer. It's a big number, but it's a really easy big number just because multiplying by hundreds and thousands are super easy. Does that make sense to everyone?
Yeah.
Yeah, good. Okay. What about D? If you want, submit your answers to chat and I will give you feedback to the chat as well if you want. I know that one's a bit ugly, but it's a lot better than doing them separate square first. Okay, can someone help me with part D? Can someone tell me what the first step I should do here is?
161 times 161. So square 161.
That just becomes really big, and I don't want to do big numbers, right? Can we use maybe property to help me out to make it a bit nicer? What I have is a number being squared divided by another number being squared. Is there anything I can use here based on that?
161 times 23.
Not times. This
Divide.
is divided. You can do 161 divided by 23.
Which is 7.
7. So 7. Oh, that's super nice. 7 squared. I know how to do that. 7 times 7. Shit, what am I doing wrong with it? I do that in my head. That's 49. So you see, you just gotta make sure you gotta look at the properties. Maybe have this written on top of the book, and just keep referring to these. This is the properties you're gonna be using. Does that make sense to everyone else as well? Okay, with regard to E and F, if you don't have too much time left, we won't go through them fully, but what we'll do is I'll show you we'll go through the start of it instead of getting the answer. And I'll put in the homework question that we can do that for that, okay? So how would you approach E and F? We're not trying to get the answer, but how do we approach it based on using the properties? What do we do here, Sarah, for E?
You can put 144 times 35 times 25.
3 numbers. Why does it work for 3 numbers? You're right. I agree with you. The reason is this. The reason you're correct. You can do it for your life. So the idea, Sarah, right? So, which is a really good idea, and it's a correct idea. But getting the idea is justified is a little bit harder, but you don't need to. It's pretty intuitive, right? But here I'll justify it for you just because I think if it's justified, it'll be easy to use. The reason is this. What if you do this? Just apply the property to 2 numbers like we did before. Right? If I do that, just those 2 numbers, I get 144 times by 25 squared. Times by 25 squared. Right? Now we can think of this as one number and this as another number. So this is A, this is B. Right? Now if I apply it to these 2 numbers, A and B, what do I get? 144 times by 25 is one number. Times, we put a bracket around this, we just show that it's one number. Times by 25 squared. I just apply the property twice. Now I get what you said before. Does that make sense? I just applied it twice. And you can do it, if it's 4 numbers, you just do it 3 times. So you can, but you don't need to do it all the time. You just do it at once because you know it works. If it works for 2, works for 3, 4, 5, 6, 7, 8, forever. Makes sense to everyone? Have we got that? I just applied that property twice. Right? Any questions with how I did that? Because this concept is really important. It's called generalizing. We have a property that works with 2 numbers. Now we just made it work for 3. And I can, if you do the same, you can make it work for 4 numbers. We can make it work for 5, 6, 7, 8, million numbers, right? So this is called, it's a really important idea, right? What about F? What do you think we can do for F then, based on that idea? Can we do something similar to E? F? I'll take a look. So you shortcut. This way is actually nice, but don't do it very fast. Do this one first, you get nice numbers. Which trust me, long ways, that's so much longer. Okay, so for F, does anyone have ideas on how to do it, how to make it a bit easier? Here's the trick. Just like we can apply the multiplication property 3 numbers, we can apply the division property that we showed here for the top to 3 numbers as well. With this, and the way to justify is the same as we did here. So all we got to do is we could apply it to all 3 numbers, and you get your final answer here. If you find this number inside and you square it, you get the answer. Now, but we run out a bit of time. I want to move to the next section. So we'll just leave it with this section. We'll leave it here for now. And I'll put this in the homework as well. Okay? Did you get nice numbers? Yeah. So now we'll go to the next section, which is addition and squares. Okay, this will be last section, then we finish up. Okay, so before we saw just from this previous section, so guys, pay attention now. Actually, before we go, I want to say this is a really hard section, so pay really close attention. Right. So this section is hard, but while it's difficult, if you understand this, it will set you up so well for high school maths because a lot of it is based on these sort of ideas, right? So before we move on to the new section, we saw before that, a times b squared becomes what? If you expand this out, it becomes sort of reverse what we did before. Okay, that's fine, Sarah. I'll send the recording through here, just about 10 more minutes. So the last 10 minutes you can watch the recording for.
Okay.
I will see you. Hopefully you have fun in town.
Yeah. Bye.
Bye. Okay, so we have here is squaring distributed over multiplication, which before we saw a squared times b squared is a times b squared. So if you do the other way around, a times b squared becomes, you expand it out, it becomes a squared times b squared, right? So just reverse what we did before. Right? And the same with division. A divided by b squared becomes a squared divided by b squared. So we saw this property works with squaring and multiplication. We can distribute, right? We did the other way around, but we can always reverse it back. That works either way, right? So, but because that we can only, it's natural to wonder whether, squaring distributes over addition. What I mean by that is, check if, so look, a times b squared becomes a squared goes here and the b squared goes here and just becomes a squared times b squared. We're going to wonder if the same thing happens when you have addition. That means if you have a plus b squared, this just becomes the square goes here and the square goes here, becomes a squared plus b squared. Right? We're just checking if that works. We don't know that yet because we proved it last time we checked, right? We need to check this works before we actually use it. What do you guys think? Do you guys think it works or no?
Yes.
Yes. Oh, but we got one poll there. Anyone else? Yes. And to be honest, a lot of people think this works. It's one of the most common misconceptions. And the reason I'm saying misconception is because actually it does not work. Right? And it's perfectly normal because it seems so natural. Like when I first saw it, I was like, a plus b squared, the same as a squared plus b squared. Well, let's see. Let's take a look. Let's calculate 3 plus 4 squared, right? What's that going to be?
49.
Yeah, because inside becomes 7 squared, which is 49. If this property works, right, this should be the same as 3 squared plus 4 squared. I'm going to check 3 squared plus 4 squared now. What's that going to be? Three squared is equal to?
9.
Yep.
And then 16.
9 plus 16. That becomes 25.
Yeah.
Yeah. Even if it's not 25, we know for sure it's not 49, right? It's way too small to be 49. So clearly these two are not equal, right? That means this property doesn't work. Because remember, for a property to work, it must work for all numbers. If you have one number that it doesn't work for, it's done. We can't consider a property. So this does not work. So that means distributing addition over squaring does not work. A plus b squared is not equal to a squared plus b squared. So it's very important. And this is a very common misconception. You should try to avoid this. Very common. I mean, this is probably, I've talked about a little bit of misconception before, but this is the big boy one. Everyone thinks this is correct, but it's not. Right? And if this misconception was true, what do you think the answer is going to be? The answer to this one would just be 0. Because 4 squared plus 8. If this is true, there should be 4 squared plus 8 squared. Plus 8 squared minus 4 squared. Right? That's what just cancel and cancel. But it's not. So we're going to see, can you guys tell me what the answer to this one is? Calculating it properly.
We put the answer in chat.
Sure. You can always, anytime, by the way, put in the chat whenever if you have any questions as well, please feel free. All right, so shall we take a look? All right, so if you have 4 plus 8 squared, right? That means 12 squared minus 8 squared minus 4 squared, right? And that becomes 144. 8 squared is 64 minus 16. Right here, you can do this by subtracting long subtraction, whatever. Right, and if you just do the subtraction, 144 minus 64 is 4 minus 4 is 0. 4 minus 6, too small, carry 1. 14 minus 6 is 8. Because I carried 1, there's nothing left, it's 80. 80 minus 16. If you do this, you get 64. Right? So it's just 64. Does that make sense, everyone? Just gotta be careful with the working. So this idea first is simple. It's the one you need. And then after, sorry, this idea is the important one. And after that, it's just all about being careful. Because it's subtraction, right? Do not make silly mistakes there. Okay, so we'll go to the next one now. Give me a second. So now, the next section we're going to learn is a little bit advanced. So, like I said before, please pay careful attention to this one. So we know that a plus b squared is not a squared plus b squared, right? Okay, so we know it's not what it's not, but in maths, we don't know what it is. So what is it actually, right? So if we expand a plus b squared, we just figure out what is it, because we know it's only a squared plus b squared. It turns out it's actually this. It's a squared plus b squared. Actually, I'll put it on the side. I want to put something else in the middle. Plus something else. Now something else turns out to be we're looking term 2ab. So this is what's happening. It's a squared plus b squared plus this really weird looking term 2ab, right? And we'll finish off by I'll show you a really cool proof why this is true, right? So just follow along with this diagram. So we got this diagram here, right? Okay, if I ask you the area of the big square, what's that equal to? What's the area formula? Just like length squared, right? What's the length of this big square? So big square here, like this big square. What's the length of one of these big squares?
8 times b. A plus b to the power of 2.
Plus b, right? So it's given us, yeah, a plus b to the power of 2, a plus b squared. So we know that it's a plus b squared, right? But we also know that the area of the big squared is just the same as all the area of these smaller squares. And color them. This one, this one, this one. So the smaller squares and rectangles added together. Because they fit in perfectly. So what's the area of this square here? On the left corner.
A to the power of 2.
Yeah, just a squared, right? A times a. And it's good to, if you can draw a diagram like this, just for things yourself as well, because that will make a lot more sense. What about the area of this rectangle here?
E plus a to the power of 2. Yeah.
What's the length of this rectangle? Oh, sorry, length is this one, longer one. It's just a, right? Because it's the same as this side here. and the width is just b, just given. That means the area is what? Area is just length times width. It's we have width of b here and length of a here, right? That means area is just length times width, which is a times b. Right, as ab. Does that make sense?
Yep.
Please, just this one's a little bit weird, so I want your feedback on this. So please let me know if you have any confusion. So if I ask you a question, please try to answer. Just because this is going to be a really weird idea initially, but it's going to be one of the most important things you learn in probably high school maths, right? So this is actually good for your future. Like, gives a head start, right? So what about this rectangle in the left corner here? What's the area of that? What's its length and width, I guess? What's this length here? What here? I think the length's gonna be. Oh, up to Arjun. Remember, this length up top is A. That means the length up the bottom is the same. So it's also going to be A. That means the area of this rectangle at the bottom is also length times width, which is A times B. Right? So it's AB. What about the area of this real rectangle in the corner now? So the little square in the corner. What's this length? I'll show out with this same thing. Same as this, which is B. What about this one? What do you think is the same as? Look on the other end, because remember this one's the same as this. B. So that one's also B. Does that make sense why they're both B? Both length this one and this one are B. Please let me know. Because it's a really tricky idea, so I want to see if you're on the same page as me. So it's B and B. That means the area is B squared. Okay. Now, if I just add all of these up together, that's the area of the full rectangle. So if I add all four of these numbers together, what do I get? So area of rectangle.
A squared plus B squared plus AB to the power of 2.
Not power. I'm just adding them together.
Oh.
If I'm adding them together, now I have two of them, right? So that's because if it's power of 2, if I multiply them together, I'm just adding them together, right?
2AB.
Yep, 2AB. If I just rearrange this, it just becomes A squared plus 2AB plus B squared, which is what we had here. And now we're done. That's the proof. We'll go into this much more in depth next week, but that's the start of this. Very important idea. It's super important in high school. If you guys pay attention here next week, a little tricky, but it will set you up really well for high school maths, okay? So do you have any questions with that before I finish? No? Okay. So that's the area of the square, way to do it, and we'll go through this next week as well. But this is a really, really important idea. And yeah, hopefully this will make more sense. All right. We'll finish there. And I'll see you guys next week.
See you. Bye.
Bye. You want me to take this, or if you want, I might change the handout. I might update if you want. So. Okay. All right. So hey, Arjun.
Yep.
So I see you understand the concept super well. Like But it's just you make a couple silly mistakes when you do the calculation.
Yeah.
So we'll talk for a little bit just to see if there's any strategies to sort of avoid them, I guess.
Okay.
When you learn, like, how comfortable do you feel with long multiplication and long addition and stuff like that?
Really confident, yeah.
Confident? Do you like, because you got the idea, I feel like maybe, I'm just guessing, so because I'm not fully sure, please tell me if I'm wrong. I feel like maybe you sort of rushed the answer just because once you get the big idea, maybe afterwards.
Yeah.
Yeah, so just because, I mean, it's fine here in the class. Hopefully in a test or something, that type of situation, if you can sort of, you got the big idea down, that hard part, you did that. Afterwards, slow it down a bit, just think what I need to do and just do it carefully. Right? Then you make less silly mistakes, because I don't want to see you like making silly mistakes after doing everything else right.
Yeah, okay.
Right? Because you understand the concept really well. So I don't want to see you make mistakes afterwards, once you've already done the hard work.
Yeah.
Okay.
Thank you.
All right, no worries. Okay. I'll see you next week. Hope you have a good week. Do you have any other questions, brother? Oh no, he's gone.